We dream of finding distant worlds teeming with life and plants like our own here on Earth. The James Webb Space Telescope has discovered the first real atmosphere of a distant super-Earth. We may finally be exploring a world like ours deep in space. But 55 Cancri E holds a mystery for scientists. Located just 41 light-years from Earth, this exoplanet sometimes looks like a super-Earth and sometimes like a hellish furnace. But what is the truth? The James Webb Telescope has made a surprising discovery. To find the answer, scientists used NASA's JWST to finally get a close-up view of the Earth-like planet 55 Cancri E. Thanks to this pioneering technology, this exoplanet, our immediate neighbor on a cosmic scale, has continued to surprise scientists since its discovery in 2011. At first, the planet appeared to be a warm but rocky world that might have an atmosphere. Then scientists discovered shocking new information about Earth. Using Webb's unique analytical methods, scientists wanted to solve the mystery surrounding this mysterious planet, and they succeeded. The results were amazing. With the James Webb Telescope, we are now entering a whole new level of science, said Renu, research director at NASA's Jet Propulsion Laboratory. For the first time, we know exactly what is happening around an exoplanet, and we even get our first impressions of its surface. Imagine a boiling super-Earth. Normally, only planets that offer better living conditions than ours are called super-Earths. Typically, such planets are slightly larger, denser, hotter, and their stars live longer than our Sun. The first 2 points apply to 55 Cancri E. For a long time, we knew the planet's size, orbit, and approximate density, but we had no specific information about its atmosphere. Even its temperature was only approximate. Never before in the history of astronomy has it been possible to study a planet outside our solar system with such precision and detail. Webb's spectrometer can detect not only water, but also gases such as methane, carbon dioxide, and other volatile compounds. The more the analysis data about the planet's environment matches that of Earth, the more certain we are that we have found a true super-Earth. 55 Cancri E is one of 5 known terrestrial planets orbiting the Sun-like star 55 Cancri. The planet is nearly twice the diameter of Earth and is denser, making it a super-Earth. Previous studies of 55 Cancri E have produced strangely conflicting data. For example, a study by the Spitzer Space Telescope found that the planet orbits so close to its star that its surface may be molten rather than rocky. The planet's orbit is also thought to be tidally locked, meaning that day and night are in a constant direction. This super-Earth could be a hot place with no atmosphere, making it impossible for life to exist. Scientists have repeatedly explored this strange world. Researchers at the University of New Mexico, who have studied 55 Cancri E for more than a decade, describe the lack of clear observations as completely disappointing. A new telescope could finally shed light on the darkness and reveal the planet's secrets. 55 Cancri E has 2 atmospheres. Can a planet have 2 atmospheres? Yes. 55 Cancri E once had an atmosphere, which was then dragged away by its star. Amazingly, this dynamic planet simply grew a new atmosphere. Spectroscopic analysis has astonished scientists by providing the most detailed and comprehensive information they have ever known about the planet. Using the latest data, scientists have reconstructed the atmospheric history of 55 Cancri E precisely, and it's truly extraordinary. The extreme closeness to the star has caused the planet's surface temperature to reach about 2,400 degrees Celsius, literally burning away its protective shell. But this exoplanet has performed a miracle, replacing its original hydrogen and helium atmosphere with a new atmosphere formed from gases released from the planet's rocky interior. This secondary atmosphere is composed primarily of carbon dioxide and carbon monoxide. You might wonder how JWST can detect such detail when the light from 55 Cancri E is so faint. Webb can't image the planet directly, but it measures the small changes in the system's light as the planet orbits its star. Data from the MIRI instrument show that the system's brightness decreases as the rocky planet passes behind its star, a phenomenon called a secondary eclipse. During this eclipse, the light reflected or emitted by the planet is blocked, so only the light from the star can be measured. By comparing the brightness before and during the eclipse, scientists can analyze the emission and the temperature of the planet. The analysis found that the daytime temperature of the planet was lower than expected, at about 1540 degrees Celsius. This indicates an unstable atmosphere that redistributes energy from day to night. Past data from NASA's now-defunct Spitzer Space Telescope showed traces of oxygen, nitrogen, and carbon dioxide in the atmosphere, which could be biomarkers. But how could there be traces of biomarkers in such extreme surface temperatures? One planetary scientist suggested that the atmosphere could contain metallic elements such as silicon, iron, aluminum, and calcium. These extreme temperatures could vaporize rocky material, creating a thin atmosphere of vaporized rock. This suggests that the planet may have once been colder. Just as the planets in our solar system have shifted positions over millions of years, 55 Cancri e may have once been in the habitable zone and then moved closer to its star, reaching the extreme temperatures it has today. Could 55 Cancer e have once harbored life? The planet's unusual properties continue to intrigue scientists. Conflicting measurements from different telescopes highlight the difficulty of studying it. Temperature measurements based on the planet's thermal radiation provide the first indications of a significant atmosphere. Webb's MIRI data show that daytime temperatures are much lower than expected, at about 1540 degrees Celsius, indicating that energy is well distributed between the cool night side and the warm day side. Lava flows can carry heat towards the night, where it can be recycled and cooled. But this alone doesn't fully explain the low temperatures. Further analysis using Webb's NIRCam revealed patterns in the unstable atmosphere. The team, led by planetary scientists who concluded that the features of 55 Cancri e could be related to gas emissions from its interior. Continued research could soon reveal the planet's secrets. Are you looking forward to discoveries like 55 Cancri e? Or finally proof of alien life? While hard evidence is still elusive, the James Webb Space Telescope is closer than ever. With over 5,000 exoplanets now known, Webb will continue to search for truly Earth-like worlds.